Hi there, I'm Hao, and this is just another video of me solving random code problem. So let's begin. So today we have the LRU cache. Design a data structure that follow a constraint of the LRU cache, right? We have the following method, right? We have a capacity. For get, we can return -1 if that doesn't exist in our cache, and we can return the value to the key if it exists, right? For the put, if the key exists, then we update the value. Otherwise, we add it to the cache, right? And after we add it, if the size of the cache exceeds the capacity, and we want to evict the list recently used one, right? So let's say we have like a cache here, and let's say this size is the most recently used, and this size is the least recently used, right? So you can go ahead and add the element here, so 1, right? 2, and the capacity is 2, right? It is 2. So when we add 1, right, the size is the key doesn't exist in the cache yet. So we just add it, right? And then increase the size. So the size is like 1 now, right? And we keep adding 2, 2, right? And we can get 1, right? We just return the value 1 here, right? Makes sense. And we can put 3. So 3 equals to 3 because 3 is not in the cache yet. So we add it. And then now we need to so we need to add 3, right? So where do we add 3? We need to add 3 here, right? Because we just this is the most recently used. So after we add 3, the size 3 is greater than the capacity. So we need to evict the least recently used, which is on this side, right? Just 2. We can delete that. Okay. And then now we can get 2. So that doesn't exist. So we return -1, right? And then the next one is we put 4. So where do we put 4? We put 4 on this side, right? 4. And then the size 3, right? So we evict it, right? Update the size. And then after that, you get 1. 1 doesn't exist, so we return -1. We get 3 and 4, right? So 3 is here, 4 is here. So that makes sense. So how do we do this? How do we make sure that we can do it all operation in constant time? So when you add something on one side and then remove it from the other side, this makes me thinking about a queue, right? You can just add on one side and just remove on the other side. But the problem with the queue is that we cannot remove the element in the middle in constant time. You need to find the element in O of n, right? Uh, so that takes so when we delete the element, we need to reassign the index in the array. So this is not good. So instead of using a queue, we can use a double linked list because a double linked list allows us to remove a node from the middle in constant time, right? We can just reassign the pointer, right? Pretty straightforward. We can just reassign the pointer in constant time. But we can delete in constant time, right? But we have to find the node first before we can delete, right? So that is like O of n. So how do we deal with this? So we can combine the double linked list with a hash map. We can have a hash map where we keep track of the key and the value will be the node of the linked list, right? The node. So that way we can access the node and then remove it, right? In constant time. We don't need to search for it. We don't need to search for it because we have access to it in hash map. So we can combine two data structure here to um, do the get and the put operation in constant time. And also remember that when we get something, right, we need to update. We need to let's say we update let's say we get the element in the middle here. We need to remove that and move it to the front, right? to the most recently used side. So when we evict, we can evict correctly. Okay, so let view out our linked list here. Let's say I have a double linked list node, right? And we have a constructor. We have a key, default to null, and the value default to null. Use the key equal to key. Use the val equal to val. We have a previous and the next pointer, right? Default to null. Okay. And what do we want to do? We want to do two operations, right? Add and then remove from the linked list. So add and add a node here. So how do we add? It is so we add the node after the current node, right? So let's say we have a head and a tail. For these are the two dummy node, right? Pointing at each other. Let me make a space here. So head and a tail, right? This is just like no, it's just no. And we want to add a new node, right? Node. Okay. So how do we add? We can do something like this. We can do okay. So every time we want to add, we want to add to the most recently used side, right? So we can do so. Let's say this side is the most recently used side, and this side is the least recently used side, right? And we want to only to add only what I want to add on this side. So we can do head dot add, right? The new node, right? So because head is the one that's calling the method, this keyword is the head, right? Okay, so what do? We want to um, reassign the node. So we want to set the node of previous to the head, right? What is head, which is this, right? So let's do that. So node of previous equal to this, right? And then node dot next equal to this dot next, right? So node dot next equal to this, which is the head dot next, right? Okay, here, easy, right? And then what do we want to do? We want to reassign the, the head pointer and the tail pointer, right? So what is the head? The head is this, right? So we can do this dot next equal to node, right? So this dot next equal to the node, right? And same for the tail. So this uh this dot next dot previous. Okay, so we can do this dot next equal to node. Okay, before we even do that, we should do this one last, right? Because we want access to the next pointer. Let me go back here. Okay, so before we want to do this, we want to set the tail pointer first. Because if we reset the next pointer of the head, then we cannot get to like the tail, right? Like, yeah, okay. So we can do this dot next, which is the tail, the previous equal to the so this, which is the head, dot next, which is the tail, dot previous, right, equal to the node. Okay, here. And then lastly, we can do this dot next, right, which is the head, equal to the node here. Right, so now we successfully add a new node. Okay, that's pretty straightforward. Okay, how do we remove something from the linked list? So we can do something like this, right? We can do the current node, right, dot remove. Right, so now the this keyword will be equal to the node, right? Because the node is the one calling the remove method right here. So let me change the color here. Okay. So what do we want to do? We want to set the head pointer to point to the next, right, of the tail, the next of the node. So we can do node.previous, node.previous dot next equal to this dot next, right? Node.next or previous equal to this dot previous. Okay, so node, which is this one, dot previous, which is the head, dot next, which is this pointer right here, right? Equal to this, which is the node dot next, right? Which is the tail right here. Same thing, node dot previous, which is the tail. Sorry, node dot next, which is the tail, dot previous, which is this pointer right here, equal to this dot previous, right? So like this, right? And then now the only thing left to do is to remove the next and the previous pointer of the remove node, right? So we can do this dot next, next the previous equal to no. All right, and then this dot next equal to no. And we want to return this for later use. Okay, so remove this and then remove this, right? And this node will be garbage collected later on, right? So that is how you remove and then adding to the linked list. Okay, and then we can initialize our LRU cache here. So this dot head, we want to create two dummy node, right? So this dot head equal to new node, we want to tail, the tail, and we want to them to point to each other, right? And then this dot tail dot previous equal to this dot head. We want to set up our size. So this is size equal to 0. Capacity is capacity, right? And then we also want so we already have our linked list, right? But we also want our hash map, right? To keep track of the node so we can get to it in constant time without searching. Okay. So how do we get? So when we get, we want to return -1 if the value of the key is not found, right? So if the key is in this cache, we do something, otherwise we return -1, right? Okay. So remember, whenever we add something, whenever we are reading from the cache, we want to remove the node, right, and add it again to the most recently used side, right? So we can have it correctly. We can do what can we do? We can remove it from the linked list. So how how do we get the node? We can get the node from the cache, right? From the hash map, which is key, right? We can call remove node dot remove like this. Yeah, and we can add it again to the most recently used side, which is the head. So add uh, remove node. Let's just call this node. Node. Yeah. Okay. And actually, we can combine this, right? Because node dot remove will return this, right? Which is the remove node. So we can just add it directly, right? Okay. Hello? Okay, sorry. So yes, we don't want to update the size, right? Because we are just reading. So that is it for the get. And then for the put, what do we want to do? There are two cases, right? The first case is if the cache already had the value, right? So we update. Otherwise, we just add it, right, to the cache. So we want to create a new node here because like when we update, we also want to remove, right, and add it again in the most recently used side. So we always want to remove regardless, right? So we just do new node equal to new doubling this node of the key and the value here. And we also want our O value, which is just the class a key. Okay, so if key in the cache, right, and we want to update, right, else we want to remove. So if the key in the cache, we can just do actually this is not a value, this is a linkless node, right? So we can do O node dot remove, and we can do this dot head dot add a new node, right? We want to also okay, so and we also want to update the value in the cache, right? So if the key already exists in the cache, we just remove the O node, we add it again in the most recently used side, which is the head, and then we update the value in the cache, right? So else, we want to add it to the cache. So this the cache of key equals to the new node, right? And we want to also add it to the most recently used side. So this the cache that add uh the new node, right? And then we want to um, update the size, right? When we add something new, we need the size plus plus. And if the size is exceeding the capacity, then we want to evict it, the listener recently used, right? So the remove node, um, let's call this one a list recently used, LRU node, right? Which is the one at the tail, right? Remember that the tail is just the dummy node, so you want to look at the one node before. So this is the tail that previous, right? Remember, so uh, here, right? The head and the tail are just like the dummy node, right? In the like previously we have the nodes like going like this, right? So we need to do tail dot previous to look at this node right here to remove. Okay. Um. Okay. So what do we want to do? After we get the node, we want to remove the node, right? So LRU node remove, and we also want to get it from the cache, right? From the hash map, which is key. And do a remove node of key, right? Because the remove will oh sorry LRU node of key, right? And we want to decrement the size. Yeah. And that's pretty much it, right? If it is a new node, we just add it to the linked list, right? In the most recently used side, and we add it to our cache. We increment the size. If the size is too large, exceeding the capacity, we remove the least recently used one, right? We just at the tail, like head of previous. And then we also delete it from the cache and we decrement the side. So let's give it a try. So node is not defined on line 78. Oh, of course this is not the node, right? What is this? Oh, it is the disk, my bad. This is the node that we want to remove, right? This the previous dot next equal to this dot next, right? So we're just resetting the pointer here. All right, let's try again. Okay. Did I do anything wrong here? Let's see. Okay, the size, add to the linked list, update the node, update the cache. Uh, Key value here, the cache key. Oh, we have to return, right, the value if the key is in the cache, right? So I forgot to do that as well. And it worked. I see that like these two lines are the same, right? We always update the cache and then add the new node to the head, right? So we can like refactor and like move this one out. Let's try it to see if it works. Oh, actually, no, we have to do it in order. We cannot we cannot update the cache before we remove it. Okay, yeah, that makes sense. Yeah, because the key will be the same, right? So we need to remove the node first and then update the key. All right, submit. Accept it.